Okay, so let's summarize what we have discussed earlier. No? So when a regular polygon has four sides, this is the area 4p squared tangent 45. When the regular polygon has five sides, this is the area, and so on. So we have derived that if you have n sides, no, when your regular polygon has n sides, then the formula is just np squared tangent 180 degrees over n. Or we can rewrite this, that is same as, I write it n tangent 180 degrees over n, then I multiply by p squared. Now, so we can do that by commutative property for multiplication. So I'll just rewrite them together, n tangent 180 degrees over n, and I'll just write p squared here. The equation does not change by multiplication property. No? Commutativity of multiplication. Now, let's try to investigate this function or this expression, no? When n is very large already. So, as what you have mentioned earlier, when n with the number of sides of a regular polygon is infinitely many, then the regular polygon would eventually look like a square, a circle. So, we hope to see that observation in here. So, for example, we have n sides. So we have here, when n is 100 sides. So can you imagine, or can you make a regular polygon with n with 100 sides? Maybe you can, no? Or you can use software to draw regular polygon with 100 sides. So what will happen to the formula here? So that becomes 100 tangent 180 degrees over 100 times p squared. Okay? So, using your calculator, we can evaluate 100 times tangent 180 degrees over 100. So, what will you do? Be sure that your calculator is in degree mode. Because if the mode is radian, then you will have different result. So, make sure that your calculator is in degrees. So in my case, no, if you look at this one, no, okay, so degree D, okay, so that's 100 times tangent 180 divided by 100. Okay, so the answer is, okay, so this is 3.14, no? 3.14 26 6 tapos that's is a continuous decimal p squared. Okay, so it's like that. Now suppose we have 1,000 sides. Okay, so imagine if your regular polygon has 1,000 sides, it's like more of a circle, right? So you would likely you see it as a circle. So what will happen to the formula here? So in this case, you have here no, we use that one. Yeah, come on. 1,000 tangent 180 degrees over 1,000 is equal to, okay, so again, your calculator should be in degree mode, no? So that is 1,000 times tangent 180 divided by 1,000. So that is 3.1416. Okay, so this is like 3.1416 multiplied with p squared. So what have you observed with the values? It's like approaching to 3.1416, right? So can you see this value, or can you do you have some expected values for this? Yeah, that's right. So when your n, when the number of sides, no, is very big, approaches 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 to a very large. Actually, you can try 1 million here. When the number of sides, no, approaches to a very large number, mathematically we say approaches to positive infinity, or it is approaching to positive infinity. The value of this, no, the value of this expression when, this one, the value of this expression, this expression, when n is already very big, let's say 1 million, this expression is also approaching to a certain number. So that part here, this part, when n is very large, this will approach to a certain value. And what is that value? That value is called pi. So therefore, if the number of sides is approaching to positive infinity, you won't see anymore a polygon, but you see a circle, no? So you will see a circle here, no? Circle na imo makita. And what should be the area of the circle? This should be pi p squared. So the area of the circle is pi p squared. This will happen when the number of sides is very large. That means sides here are increasing without bound. So daghan, you have a polygon with infinitely many sides. So if that is the case, you are not seeing anymore a polygon, but you are seeing a circle. And because that is a circle, the area is not this n times 180 degrees p squared, but will become pi p squared.